Hi, dear students. Hope you are doing well and you are staying safe. Today, I'm going to continue for lesson 5 and we will cover pages between 124 to 127. First of all, we need to know about acid and alkali solutions. Uh, as an example, pure water can only produce a little bit hydrogen cation and hydroxy OH anion. Uh, so these are very less, and we have a very few hydrogen ions and hydroxide ions in pure water. They are equal, but very few, and also that's why the water is not very good uh, elec electricity conductor. And as we learned before, the pH of pure water is 7, and this is because of this reason the hydrogen ions and hydroxide ions, these two number are equal and very few. But acid, in acidic solution, we have more hydrogen ions. The number of hydrogen ions are more than hydroxide ions. Okay, so pH would be lower than 7, and litmus as a indicator, as we learned three important indicator. One is litmus paper can turn to red color if we have an acidic solution. And if we have an acidic solution means we have a lot hydrogen ions in our solution, and the litmus indicator show you a red color. What is acid? Acid is substance that dissolve in water. If you have any acid like hydrochloric acid, it can dissolve in water and produce hydrogen ions. Okay, that in that situation we call acid. That substance is acid. How about alkali or basic? Alkali is a substance that dissolve in water and produce OH. Okay, OH ions. When we have an alkali solution, that means we have an alkali which dissolve in water. We can say alkali solution means the number of OH hydroxide is much more rather than hydrogen ions. Okay, so also pH can be can be higher than 7, between 7 to 14, and 14 show you the highest alkali solution. Okay, the highest degree. Between 7 to 14 is alkali, and between 7 to 1 is acid, and in 7, around 7 is neutral. So both uh, both acid and alkali are electricity conductor. Okay, better than the water. What is the reason? The reason is either acid or alkali we have ions. In any solution we have ions, positive or negative, no different. But if we have ions, ions can conduct electricity, can conduct electrons. Electricity comes from the movement of electron. The electron can react with what positive or can affected by negative ions, no different. If our solution has positive or negative ion, so we have electricity conductivity. But in pure water, as I said, only less we have hydrogen or OH ions, so the electricity is very poor. So the most important characteristic property of acid or alkali that we want to define, or any definition of alkali or acid you can see is related to solution in water. We cannot define acid or alkali in uh, gas situation or solid situation. The best condition to define acid and alkali is solution in a solution condition. Okay, so when they are dissolved in water, we can define better for acid and alkali. This is importance of the water. This is the rule of water. In this situation, uh, the producing of the hydrogen ions and hydroxy ion is better and it's more clear. We need to know two definition about dilute. Dilute is when a substance is dissolved in a large volume of the water, like here. Okay, it's not concentrated, but concentrated is when you dissolve a substance is small amount of water, small volume of water. Here uh, your substance compared to water is very concentrated, is almost equal, so your substance is concentrated. But here the comparison between your substance and water, in comparison, water is a very large volume, large amount. Okay, this is two definition. uh, this picture is very important. Please focus on this picture and keep in your mind. When a non-metals, we learn in chapter 2, I think, about non-metals and metals. Non-metals are located on left periodic table, and metals are located in metals are located in left, and non-metals located on the right. So non-metal can react with oxygen, like burning, like oxygen with water, like oxygen with atmosphere, air, no different. Non-metal can react with oxygen and form acidic oxide. Okay, here non-metal oxide or non-metal can react with oxygen. They can produce acidic oxide. If acidic oxide dissolve in water, they can form acidic solution. Okay, this one. These are many examples here. Like carbon is non-metals, sulfur is non-metal, nitrogen, phosphor, they are sulfur, they are kind of non-metals. But when metal react with oxygen, like metal group 1, group 2, as I explained before, they can easily react with oxygen of the air or oxygen of the water. They can form basic oxygen, like here metal oxide. Okay, metal can react with oxygen and make a metal oxide or basic oxide. If those substance dissolve in water, they can form an alkaline solution. Alkaline, the word alkaline or basic is no different. They have the same meaning. Okay, don't be confused with basic and alkaline. Okay, if they dissolve in water, they we call alkaline solution, like here basic oxide or alkaline solution, no different. If metals react with oxygen. Okay, so the rest we have neutral oxides and amphoteric oxide. I will explain you more. Non-metals like hydrogen, carbon, or nitrogen can also react with oxygen and produce neutral oxide like monoxide carbon and waters. So they are neutral, they are not acid. Okay, neutral oxide do not react with acid or basic. Okay, they are neutral, they don't have reactivity like water, like monoxide carbon, as we learn in chapter 1, is very poisonous. And okay, we have only one here, amphoteric oxide, which a reaction between metals with oxygen. Okay, they can produce metal oxide. One type is amphoteric oxide, like zinc oxide, like aluminum oxide. I will explain you next slide. Okay, what is amphoteric oxide? Amphoteric oxide is a substance that can play as an acid or basic. They can react with another basic or another acid. They can play a role as an acid or basic. If it is acid, it can react with basic. If they are basic, they can react with acid. Okay, so they can take a two position, both acid and basic. Finally, what happens if they react? They can produce salt and water, a kind of kind of salt. In chemistry we call salt, not that salt we are eating, not that one, but the type of molecular structure, the compound is salt, called salt. Aluminium and zinc, they are the most important example for amphoteric oxide. Okay, amphoteric, I said, okay, the kind of metal react with oxygen, they can produce amphoteric oxide. The most important metal are aluminium and zinc. So here you can see, for example, aluminium. Okay, we have aluminium. Aluminium oxide can react with hydrochloric acid, with another acid. So here it can take a position as a basic, and they can produce a kind of salt, as I said here, and water. The rest is water. So here aluminum acid play as a basic. Another one, also this aluminum oxide can react with sodium hydroxide. Sodium hydroxide is a basic. So here it's playing a role as an acid. So in these two equation, aluminum oxide can be acid, can be basic, and also can be acid, both. Okay, and the rest can react with another acid, or if it's basic can react with acid. If it's basic, acid can react with another basic. Okay, the rest, the production, are salt and water. So this is amphoteric oxide. I hope you learn. I try to teach you very in a simple way. And finally, please leave a comment down as your attendance. Thank you so much. Take care.